Measure airflow like a pro with the heating, ventilation, and air conditioning temperature rise formula to calculate cubic feet per minute using supply minus return. Temperature differential, input heat, and fan heat for accurate furnace airflow diagnostics and faster heating, ventilation, and air conditioning troubleshooting. Start by taking stable return air and supply air temperatures with a fast response thermistor placed out of line of sight of the heat exchanger to avoid radiant skew. Average several readings across the airstream for both supply and return to lock in a reliable temperature differential. Confirm the furnace input rate with a clocked gas meter or nameplate electric heat kilowatts, then subtract blower motor heat using measured voltage, amperage, and power factor to derive true net heat to air. Use the core formula. Airflow cubic feet per minute equals net heat to air divided by air heat content, where air heat content equals 1.08 times temperature differential for sea level dry air. Correct the 1.08 constant for altitude and humidity using density correction. For electric heat, net heat in British thermal units per hour equals kilowatts times 3,412 minus measured motor wattage. For gas, net heat equals actual input times combustion efficiency times heat exchanger transfer efficiency verified by steady combustion analysis. Cross-check the result with external static pressure and the blower fan table. If the table predicted cubic feet per minute and the temperature rise cubic feet per minute disagree by more than 10%, re-verify readings before changing tap speeds. Keep supply plenum sampling at least 12 inches downstream of the heat exchanger or electric elements and upstream of any bypass or humidifier injection to avoid mixed air errors. Stabilize the system for at least 10 minutes at steady state firing before logging data. Short cycling or staged heating transitions will fake a drifting temperature differential. Document filter type, duct size, register's open count, and coil condition so future tests are comparable and reproducible. One of the biggest heating, ventilation, and air conditioning airflow testing mistakes is trusting a continuously rising temperature differential as normal when performing the temperature rise cubic feet per minute test. In search engine optimization terms, that drifting delta T signals insufficient blower speed, airflow restriction, or air handler control faults, so fix it by increasing blower tap or programming a higher cubic feet per minute per ton, then retesting after stabilization. Another common heating, ventilation, and air conditioning problem tied to airflow calculation keywords is measuring supply temperature too close to the heat exchanger, which inflates the temperature differential and collapses calculated cubic feet per minute. Relocate the probe, average multiple points, and shield from radiant heat to stabilize the reading. The third frequent airflow testing error is ignoring duct static pressure and filter pressure drop. While relying only on the temperature rise formula, pair the test with a manometer, compare total external static pressure to blower charts, replace restrictive filters, open closed registers, clear evaporator coil fouling, and correct undersized returns to stop the temperature differential from creeping upward during the run. BigHomeProjects.com features a vetted directory of heating, ventilation, and air conditioning contractors who know airflow diagnostics, temperature rise testing, and proper blower setup, helping homeowners find trusted local pros for accurate furnace performance testing and repairs. Contractors use BigHomeProjects.com to showcase verified reviews, licensing, and specialty services, connecting them with homeowners who need expert airflow balancing, ductwork improvements, and heating, ventilation, and air conditioning system optimization.